The quadrilaterals discussed in this section have two pairs of congruent sides. In this section, theorems 4.2.1 to 4.2.3 take the form if ... then this quadrilateral is a parallelogram. In this section, we find that quadrilaterals having certain characteristics must be parallelograms. Theorem 4.2.1. If two sides of a quadrilateral are both congruent and parallel, then the quadrilateral is a parallelogram. Given in figure 4.12a, segment RS is parallel to segment VT, and segment RS is congruent to segment VT. Prove RSTV is a parallelogram. Proof. Statements. Reasons. Statement 1. Segment RS is parallel to segment VT, and segment RS is congruent to segment VT. Reason number 1, given. Statement number 2. Draw a diagonal segment VS. See figure 4.12b. Reason number 2. Exactly one line passes through 2 points. Statement number 3. Segment VS is congruent to segment VS. Reason number 3. Identity. Statement number 4. Angle RSV is congruent to angle SVT. Reason number 4. If two parallel lines are cut by a transversal, alternate interior angles are congruent. Statement number 5. Triangle RSV is congruent to triangle TVS. Reason number 5. Side angle side. Statement number 6. Angle RVS is congruent to angle VST. Reason number 6. CPCTC. Corresponding parts of congruent triangles are congruent. Statement number 7. Segment RV is parallel to segment ST. Reason number 7. If two lines are cut by a transversal so that alternate interior angles are congruent, these lines are parallel. Statement number 8. RSTV is a parallelogram. Reason number 8. If both pairs of opposite sides of a quadrilateral are parallel, the quadrilateral is a parallelogram. Theorem 4.2.2. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Another quality of quadrilaterals that determines a parallelogram is stated in Theorem 4.2.3. Theorem 4.2.3. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. When a figure is drawn to represent the hypothesis of a theorem, we should not include more conditions than the hypothesis states. Relative to Theorem 4.2.3, if we drew two diagonals that not only bisected each other but also were equal in length, then the quadrilateral would be the special type of parallelogram known as a rectangle. We will deal with rectangles in the next section. The next quadrilateral we consider is known as a kite. This quadrilateral gets its name from the child's toy pictured in figure 4.13. In the construction of the kite, there are two pairs of congruent adjacent sides. See figure 4.14a. This leads to the formal definition of a kite. Definition. A kite is a quadrilateral with two distinct pairs of congruent adjacent sides. The word distinct is used in this definition to clarify that the kite does not have four congruent sides. Theorem 4.2.4. In a kite, one pair of opposite angles are congruent. In example 2, we will verify Theorem 4.2.4 by proving that angle B is congruent to angle D. With congruent sides as marked, angle A is not congruent to angle C. Given kite ABCD with congruent sides as marked. See figure 4.14a. Prove angle B is congruent to angle D. Proof. Statements. Reasons. Statement number 1. Kite ABCD. Reason number 1. Given. Statement number 2. Segment BC is congruent to segment CD, and segment AB is congruent to segment AD. Reason number 2. A kite has two pairs of congruent adjacent sides. Statement number 3. Draw segment AC, figure 4.14b. Reason number 3. Through 2 points, there is exactly one line. Statement number 4. Segment AC is congruent to segment AC. Reason number 4. Identity. Statement number 5. Triangle ACD is congruent to triangle ACB. Reason number 5. Side, side, side. Statement number 6. Angle B is congruent to angle D. Reason number 6. CPCTC. Corresponding parts of congruent triangles are congruent. When observing an old barn or shed, we often see that it has begun to lean. Unlike a triangle, which is rigid in shape, figure 4.15a, and bends only when broken, a quadrilateral, figure 4.15b, does not provide the same level of strength and stability. In the construction of a house, bridge, building, or swing set, note the use of wooden or metal triangles as braces. The brace in the swing set in figure 4.15c suggests the following theorem. Theorem 4.2.5. The segment that joins the midpoints of two sides of a triangle is parallel to the third side and has a length equal to 1/2 the length of the third side. Refer to figure 4.16a. If M and N are the midpoints of segment AB and AC respectively, theorem 4.2.5 claims that segment MN is parallel to segment BC and the length of MC equals 1/2 the length of BC. In triangle RST in figure 4.17, point M and N are the midpoints of segment RS and RT respectively. A. If length ST equals 12.7, find length MN. B. If length MN equals 15.8, find length ST. Solution. Part A. Length MN equals 1/2 length ST. Length MN equals 1/2 times 12.7. Length MN equals 6.35. B. Length MN equals 1/2 length ST. 15.8 equals 1/2 length ST. 2 times 15.8 equals 2 times 1/2 length ST. 31.6 equals length ST.